Yes, so like I did inform you, today we'll look at the topic earthquakes. We'll look at earthquakes, and then we'll look at the issues once we delve into it. Um, so let me quickly take you through the lesson overview. And then, so the lesson overview. In the course of this lesson, we will be looking at the definition of an earthquake, causes of earthquakes, and earthquake measurement, how we can measure earthquake across the world. And then you should also we'll also be looking at a few examples of earthquakes across the world. Then we'll also consider shock waves. We'll also consider shock waves. And then we'll look at the effects of earthquakes. And then we'll also be considering some safety tips. In other words, measures to take or things to do in event of earthquake or during an earthquake phenomenon. All right. Now, what are our learning objectives? What are we hoping to achieve at the end of this lesson? First of all, you should be able to define an earthquake. At the end of this lesson, you should be able to define an earthquake. Then again, you should be able to identify the causes of earthquakes. The causes of earthquakes. You should be able to identify the causes of earthquakes. Then you should also be able to examine the measurement of earthquakes, how we measure earthquakes across the world. Then we'll continue, and then you should be able to give examples of earthquakes across the world. You give examples of earthquakes across the world. Then also you should be able to identify the various types of shock waves. You should be able to identify the various types of shock waves. And then finally, you should be able to explore some safety tips or things to do during an earthquake. These are just safety tips, safety or preventive measures in event of earthquakes. What are you supposed to do as an individual during an earthquake? So basically, this is our learning objectives. This is a broad area we are hoping to cover at the end of this lesson. Now, before we, I believe last 2 weeks or so, before we ended the lesson on volcanicity, I did inform you that this week we shall be looking at the topic earthquake. And for that matter, I encourage you guys to go and at least read on the topic, to go and read on earthquakes, so that when you come, you'll be able to, or you'll be in a better position to comprehend the lessons as we continue. So I believe most of you have done that. So let's quickly proceed and look at the definition of an earthquake. How do we define an earthquake? How do we define an earthquake? But then before we define an earthquake, or before we look at what an earthquake is, this is not a new term. I believe most of you have been hearing of these issues or phenomenon of earthquake across the world, perhaps in the news or on the television. So one will ask these things that reporters talk about, or these things that happen across the world, and then we find it in the news or in the radio. What actually is it? What is an earthquake? So let's look at the definition of an earthquake. The definition of an earthquake. All right. Now we define an earthquake. We can simply define an earthquake as the shaking or the trembling of the ground. We can simply define an earthquake as the shaking or the trembling of the ground caused by waves of energy, caused by waves of energy called seismic waves. This seismic waves or the energy, we shall be looking at them once we proceed or once we continue with the lesson. So in the course of the lesson, you will know what we mean by seismic waves or what we are referring to as the waves of energy. Now, we can also define an earthquake as a violent tremor in the Earth's crust. We can define an earthquake as a violent tremor in the Earth crust, which sends out series of vibrating waves, in all directions. All right, so simply, this is the definition of an earthquake. Basically, this is how we define an earthquake. It's just the shaking or the trembling of the ground caused by waves of energy, which we basically call seismic waves. Now, having looked at the definition of an earthquake, let us then proceed to look at the possible causes. What brings about an earthquake phenomenon? How do earthquakes occur? So we look at the causes of earthquakes. But before we look at the causes of earthquakes, are you aware that just recently, I think last 2 weeks or so, we have this earthquake phenomenon occurring in Ghana, precisely in Accra? Are you aware?
No, say.
You're not aware. Don't you guys listen to the news?
No.
Yeah.
Yes,
We are aware.
You're aware. Yeah. So let me see who says he or she is
Yes.
aware. Who is that? Yes, Bansa. Okay, you said you are aware, right?
Yes.
So when did it happen? When did it happen? What was the nature?
I only heard the news.
You only heard the news
I
that
only saw
that
it
there
on
was an
the
earthquake.
internet.
Oh, okay, you read it on the internet.
Yes.
That there was an earthquake in Ghana and then for that matter, Accra. All right. That is good. It's good to always be hungry for information.
Yes.
As students, you don't rely solely on the information you get from your various textbooks. The information you get outside the textbook is also important. So take note. All right. So let's look at the causes of earthquakes. What brings about the phenomenon of earthquake? How do earthquakes develop or occur? So that is what we are going to look at. There are a number of causes, or there are a number of factors or reasons behind the development of earthquakes, how earthquakes develop or come about. So these are basically what we shall look at. The first cause of an earthquake. So we are saying earthquakes occur as a result of movement on faults within or below the earth crust. So if you have movement of faults within or below the earth crust, this can result in an earthquake. I think I took you through plate tectonics, right?
Yes, sir.
We did plate tectonics, and then we did faulting. Faulting. we did faulting, right?
Yes.
All right. So deep within the Earth crust or beneath the Earth surface, when there is a fracture or when there is a crack within the crust, and then you happen to have two opposing plates or faults coming into contact. Once they come into contact, there's that probability or that potential to send out shock waves, So these shock waves are basically sent to the surface of the earth or the ground surface. And when they are experienced or when they materialize at the surface, they come out as what? Earthquake. So basically, this is what, or this is about the fault, how fault or movement within the earth crust or below the earth crust can result in an earthquake. Are you okay?
Yes, sir.
All right. Then also, uh, during explosive volcanic eruptions, during explosive volcanic eruptions or violent volcanic eruptions, eruptions that are associated with massive explosions. Examples like volcanic bombs and other forms of explosions. Now, this kind or this nature of explosions can sometimes send out vibrations. It can be associated with vibrations once the eruption is taking place. It can be accompanied with vibrations within the crust, within the Earth crust. So these vibrations uh, may eventually manifest or materialize at the surface of the Earth or at the ground surface. And when this happens, it sends out series of vibrating waves, which we can experience at the surface as an earthquake, which we can experience at the surface as an earthquake. So take note, in the event of explosive or violent volcanic eruptions, there's a possibility, depending on how massive or how huge the explosion is, there's a possibility of uh, uh, this eruption sending out series of vibrating waves, and these vibrating waves can be experienced at the ground surface or at the surface of the earth. So this will materialize or will result in the vibration or the shaking of the ground surface, which is the earthquake we are referring to. So take note. Then again, earthquake can also occur when subducting plates slide into the mantle, the Earth's mantle. When subducting plates slide into the Earth's mantle, this can also send out series of shocks or vibrating waves. Once this plate, once it slides into the mantle, and then perhaps comes into contact with another plate, as it slides past the plate into the mantle, once there is contact, there's a possibility of uh, a, a, a shake or a shock. And when these shocks occur deep within the crust or in the mantle, there's a possibility of these shocks emanating or materializing at the surface of the earth or at the ground surface. So when these shock waves deep within the crust or in the mantle, when they come onto the surface or when they are experienced at the ground surface, then it comes out as an earthquake. All right. Now, in the event of an earthquake, depending on the shock wave involved or the energy involved, the energy involved will determine whether the shock will be experienced or will be felt at the surface or will not be felt. So there are a number of contacts or plates colliding deep within the earth crust or in the mantle that we do not experience at the ground surface. So this may be simply due to the fact that these waves energy are not strong enough to send the expected vibration we are expecting at the ground surface. So yes, we may have series of shock waves or seismic energy deep within the earth crust or deep below the earth crust, which we may not necessarily experience at the earth surface. So which may not materialize at the earth surface as an earthquake. Those that are strong enough, those that are strong enough, those that involve massive energy are likely to send out these waves, which we eventually experience at the ground surface as an earthquake. So take note. Then again, still on the causes of earthquakes, uh, in a highly sophisticated mining environment, in a highly sophisticated mining environment, we are talking about the huge underground mining activities. Now, the technology or the machine involved in this sort of mining are quite sophisticated. They are quite complex. So during rock blast, when underground miners in their quest to uh, uh, get the gold or the other minerals once they are mining, may resort to blasting rocks under the ground, under the earth crust or below the ground. So once this blasting takes place, the blast may sometimes send out vibrations or energies, shock waves, depending on uh, the intensity of the blast as it is occurring under the ground. So this activity has the potential to send out waves or vibrations that can be felt at the surrounding area where the mining activity is taking place. So when this happens, when this activity by miners underground in event of blasting rocks in order to explore the precious minerals in a particular area leads to series of vibrations in the area, we can refer this to as an earthquake. But these are somehow small or smaller quakes. Okay, they can hardly be noticed because these are not natural phenomenon. They are not caused naturally. They are not caused naturally. They are as a result of what man's interference within or man's activities deep underground. So this kind of shaking or trembling are not usually so huge as we may see in other cases that result from natural causes, whereby we have plates colliding, we have fractures or faults developing deep within the crust. Compared to the activity of mining, these quakes may not be so severe. So sometimes they can hardly be noticed. All right. Are we clear with the causes of earthquakes?
Yes, sir.
Yes, sir.
All right. So, Savannah, Savannah, are you there? Savannah cannot hear me. Can you hear me? Grace, are you there?
Yes, sir.
Yeah, so you understand the meaning of an earthquake, right?
Yes, sir.
So tell me what an earthquake is.
Say an earthquake is a shake.
Yes, we are listening.
Say it is a shake natural phenomenon that occurs within the earth crust.
It is a natural phenomenon that occurs within the earth crust. So all right, okay. So the activities of miners, the underground miners, the activities that result in the shaking or the trembling of the ground surface, would that also be considered as a natural phenomenon?
No, say.
All right. So you have to be careful once you are trying to define some of these terms, so that uh, you don't put yourself in a difficult situation once you are trying to define or explain this concept. Emmanuel, Emmanuel,
Yes, sir.
tell me what an earthquake is. How do you define an earthquake?
Yes, sir. So an earthquake is simply the shaking or trembling of the ground caused by waves called seismic waves.
Can you come again?
Earthquake is simply the shaking or trembling of the ground caused by waves called seismic waves.
It simply refers to the shaking or the trembling of the ground caused by waves of energy
Yes, sir.
known as what? Seismic waves. All right. So simply the shaking or the trembling of the ground, the shaking or the trembling of the ground, the ground surface, the earth surface, caused by what? Waves of energy. Waves of energy. These waves of energy are simply vibrations, vibrations that are felt at the surface of the earth, or that are felt at the earth surface. So when we experience these vibrations in a form of shaking or trembling of the ground, then we refer to this as what? An earthquake. All right. So we have looked at the various causes of earthquakes. So all the points that are illustrated here, all the points that are indicated here can result in an earthquake or can bring about an earthquake phenomenon. So take notes. Take notes. All right. Um, do you have any question on the causes of earthquakes? Have you come across any other way by?
Say,
Yes.
say, please, is there any difference between earthquake and volcanicity?
Yes. Yes, there's a difference. There's a difference. Volcanicity, who can answer that question? Who can answer that question? Grace is asking if there is any difference between earthquake and volcanicity. Who can answer? Bansa, can you answer? Can you answer that question?
Say no.
Hey, don't you know the definition of an? Don't you know the definition of volcanicity?
Yes, please.
Don't you know the definition of an earthquake?
Yes.
So, having known the definition of volcanicity and then that of earthquake, try and see whether you can put
Okay.
yes, try and
Okay.
see whether you can differentiate between the two.
Volcanicity deals with the flow of molten magma,
Uh-huh.
but earthquake deals with the shaking and trembling of the ground caused by
All right, all right. So that is excellent. That is excellent. You have tried. Grace, are you there?
Yes,
Yes.
sir.
Yes. So there is a difference. There is a difference between volcanicity and an earthquake. Now, volcanicity, as we learned, comprise of all the processes by which molten materials or molten rock are ejected or are erupted into the earth crust, or onto the surface of the earth, onto the surface of the earth. So all the processes, all the mechanisms through which molten material or molten rock comes out into the earth crust or find themselves into the earth crust or possibly come to the surface of the earth, which are visibly seen. They are basically what we are referring to as volcanicity. Shadrach, I'm coming. Then I see your hand raised. I'm coming. But then when we talk of earthquake, this is basically or simply the shaking of the ground surface. Okay. Earthquake simply has to do with the trembling or the shaking of the ground surface caused by waves of energy. This has nothing to do with the movement of molten rock or molten material from great depth below the earth crust, which eventually find themselves or its way into the earth crust or onto the surface of the earth. So these are two different concepts. These are two different concepts. Do you understand?
Yes, sir.
All right.
Yes,
So
sir.
the factors that cause or brings about earthquakes are sometimes or somehow different from the factors that result in volcanicity. How volcanicity comes about is quite different from how an earthquake phenomenon occurs. All right. Shadrach, I see your hand up.
Yes, sir.
Yeah, so
The note for the earthquake. Will you
the
be
notes.
sending it to us?
Yes, yes.
Yes.
Obviously, I used to do that. So surely you'll be having access to the slides. This is just a slides. I'm just using this to teach. This is not a note.
Okay.
So yes, you can't rely solely on this. It's
Okay.
just to guide you as you probably make your own notes or as you study. Are we clear?
Okay.
All right.
Yes, sir.
All right. So we can continue. We can continue. Do you have any other question? Do you have any other question regarding the causes of earthquake?
No, sir.
Um, all right. Then we can continue. Let's continue and then look at how we can possibly measure an earthquake. So look at the measurement of earthquake. We look at the measurement of earthquake. In events of an earthquake or during an earthquake phenomenon, how do we determine the intensities or the severity of the quake? How do we determine even the location where the earthquake originates or where it has happened? How do we determine all this? So the measurement, the processes involved in a measurement will help us to identify some of these things. All right. So first of all, earthquakes are measured and located using certain instruments. There are a number of instruments that are used to measure and then locate earthquakes once they happen or occur across the world. Just like we have a number of instruments that are used to detect the temperature of the human body. That's the thermometer. We have quite a number of so many types of thermometers that are used to determine the temperature of the human body. We have quite a number of instruments and gadgets that are used to measure and then determine the location of earthquakes once they occur in a particular area or in a particular region. So take note. One popular instrument is what we call the seismometer. The seismometer. And this is an instrument used to measure the amount of ground motion. This is the instrument used to measure the amount of ground motion. Beyond that, the seismometer also finds the location and then the depth of the earthquake once it occurs. Once it occurs. Very soon, we shall be looking at how the entire earthquake phenomenon occurs. First, there's a point of contact, there's a point of focus, and then once there is this focus or contact, then shock waves begin to originate or emanate or travels from both this focus or source origin before the shocks are sent into other directions. So the seismometer, first of all, will help us to measure the amount of ground motion. And then it also helps us to find the location and then the depth of the earthquake. The depth of the earthquake. The depth of the earthquake simply means how deep from the ground surface, how deep beneath the earth crust, how deep or the extent below the earth crust that the earthquake phenomenon has developed. It can also be detected. So the seismometer will help us to find the location as well as the depth of the earthquake. Then also we have a seismograph. A seismograph. A seismograph is basically a recording device. A seismograph is simply a recording device. And this recording device measures the intensity of an earthquake. It measures the intensity of an earthquake. And by intensity, we are looking at the extent of damage, or the size and then the power accompanied by the earthquake phenomenon, and then the environment in which the earthquake has occurred. So we are looking at the damages, the extent to which disruptions have taken place within the environment. And this is the intensity we are looking at. So the seismograph, this recording device, will help us to measure the intensity of the earthquake. Is that clear? And the intensity finds the extent and the kind of damages in the environment caused by an earthquake, as I said earlier. All right. Then we have the size or the power of an earthquake. The size and then the power of an earthquake. How heavy or light the earthquake phenomenon is can be measured using a device known as the Richter scale. We can measure the size or the power of an earthquake using a measuring device known as the Richter scale. The Richter scale. And it is one of the oldest means of measuring an earthquake. One of the oldest devices used to measure an earthquake phenomenon. All right. So this instrument or this measuring device was first devised by a very popular American physicist, known as Charles Francis Richter. Charles Francis Richter. He is an American physicist, and then he devised, or he came out with this measuring device in the year 1935. In the year 1935. Now, on a Richter scale, the scale is graduated from or is graded from 0 to 9. So you find the grade on a Richter scale from 0 to 9. And this grade is where we find the various numerical values for the phenomenon of the earthquake once they occur. We can find the values between these two digits, the 0 and then the 9. So the Richter scale calculates the amount of energy. It calculates the amount of energy released during an earthquake. So the size of the power, the amount of energy released during the phenomenon of an earthquake or during event of an earthquake can be measured using the Richter scale. Now, this measurement, once the measurement is detected using the Richter scale, will give us an indication, as to the magnitude of the earthquake. The magnitude of the earthquake. What is the magnitude? Simply, the magnitude is the amount of energy. It is the amount of energy or the amount of shock waves that is measured and recorded on the Richter scale. So the amount of energy or shock waves that is recorded and measured on the Richter scales give us the magnitude of the earthquake. So if there is an earthquake phenomenon in a particular area, in a particular region, and this energy or this shock wave is recorded on a Richter scale, then we can be able to determine the magnitude. We can determine the magnitude of the earthquake. And the magnitude is simply what? The intensity of the quake. All right. Now, take note of this. On a Richter scale, I told you it's graded from 0 to 9. So when you have higher numbers on a Richter scale usually indicate larger earthquakes, and the amount of ground vibration. The amount of ground vibration depends on the size or power of the earthquake. Depending on how huge the vibration and then the devastation that is experienced on the surface of the earth depends on the power, how strong the earthquake is. So take note. Now, on the measurement of an earthquake, we have quite a number of seismograph stations positions across the world. We have a number of them, positions at vital points, locations across the globe. So once we have a phenomenon of earthquake, once there is the development of the earthquake, these seismograph recording devices are able to quickly pick or record the intensities of these quakes once they occur. All right, so one can quickly go and then pick out this data or this information from these devices once they capture the information accompanied by the quake. All right, let's look at the Richter scale. The Richter scale. We indicated that on a Richter scale, it is graded from 0 to 9. So if you happen to find values from 0 to 3, what does it mean? If you have an earthquake magnitude ranging between 3 and 4, what does it mean? What is its implications? If you find a magnitude of an earthquake ranging between 5, 6, and 7, what are the implications? So we'll look at this as well. All right. So first of all, we'll look at the Richter magnitude. the Richter magnitude, or basically the energy. The energy recorded on the Richter scale is what we are referring to as the Richter magnitude, or the energy. Now, this energy can fall within the values of 0 and 9. This energy can fall within the values of 0 and 9. So when you get these values, what are its implications? So the possible effects or the implications of these values will also be given. So basically, this is what we are going to look at. We look at the Richter magnitude, or the energy of the earthquake, and then we'll look at its implications or the possible effects. Now, the first one, if you have an earthquake magnitude of 2, I told you earlier the magnitude is graded from 0 to 9. So from 0 to 9 will give you whether the energy or the magnitude recorded will indicate whether the earthquake is severe, whether it is just a mild one, or whether it's just a minor event. So if you arrive at a numerical value of 2, if you arrive at a numerical value of 2 measured on a Richter scale, you have an earthquake magnitude of 2. What does it mean? What does it mean? Now, the possible effects or the implications simply would just be that it will be very difficult for persons or even inhabitants of that particular area where the earthquake phenomenon occurred to even sense or even detect that an earthquake has happened. So what I'm basically saying here is that when you have an earthquake magnitude of 2.0 or 2, what it means is that people may not even notice that an earthquake has occurred. That is simply what I'm saying. If you have an earthquake magnitude of 2.0, which is an earthquake phenomenon, people or individuals may not notice or may not even detect that an earthquake phenomenon has occurred. All right, but yet the Richter scale or the instrument will be able to pick some information. That is when it is 2. All right. Let's look at the other values. Now, let me be quick to also say this. Normally, when you have magnitude values of ranging from 0.1 to 4, if you have magnitude values of 0.1 to 4, normally we don't refer to them as earthquakes. We don't refer to them as earthquakes. We basically refer to them as earth tremor. We call them earth tremors. So what happened in Accra last 2 weeks? I think it was Wednesday, last 2 weeks Wednesday. That should be 24th June 2020 in Accra. Per the information I have, the magnitude picked up or recorded was around 4.0. So this will be regarded as an earth tremor. Not an earthquake. The tremor is just a very mild vibration. It's just a very mild vibration that is experienced at the surface of the earth or at the ground surface. They are not so huge or so destructive in nature that may lead to destruction of infrastructure and other installations. So take note of this, very, very important. Now, when you have a Richter magnitude of 4.5, or you have an earthquake energy recorded on a Richter scale giving you a magnitude value of 4.5, what are the possible implications or the possible effects? You are likely to see minor damages, or what we are calling structural damages. This may result or may cause cracks. This may cause cracks to develop on walls. This may not be a major destruction or a major structural damage. So you see minor cracks developing on walls of buildings. So this is an indication that the energy or the magnitude of the quake as measured on a Richter scale is not so huge. It's not so huge, or it's not heavy enough. So yes, what happened in Accra recently led to some cracks developing on walls. It also led to some portion of our road networks in Accra developing some cracks, which is visible. People saw it. So that is for the magnitude or the energy, a Richter energy of 4.5. Now, I did indicated earlier that when you have higher values means that the quake is quite severe, or the quake is heavy or massive. When you have a lower value, or when you have lower values, these are just mild vibrations that sometimes it cannot even be noticed. Sometimes it cannot even be noticed. So take note. Now let's proceed. Now, if you have an earthquake measuring on a Richter scale, measuring about 7.0 or 7 magnitude on a Richter scale, this can be considered as a major. This can be considered as a major earthquake, a major earthquake. And when this happens, you are likely to see buildings getting destroyed, or buildings getting destroyed or falling, or yes, destroyed. So there is this yes, normally when you have high-rise buildings, or how you call story buildings. Now, story buildings are likely to experience the effects of such an energy. If you have an earthquake energy magnitude given a value of 7.0, then basically buildings and other structures are likely to feel the impact of such a vibration or such an energy. So you end up seeing most buildings collapsing, or most buildings getting destroyed. When that happens, we say that the earthquake is a major one. The earthquake is a major one. So depending on the value or the energy measured, we can determine whether the earthquake is a major one, whether it's a minor one, or it's just a phenomenon that can be barely noticed. So take note. Now, what of if you have a Richter magnitude or energy of 8 or 8.0? A Richter magnitude of 8.0 or 8. Now, these are considered as severe or great earthquakes. We refer to them as severe or great earthquakes. And when such earthquakes come about, or when such earthquakes occur, they are usually associated with massive destructions. The destructions are quite heavy. They are quite huge. They are quite huge. So if you hear in the news of an earthquake magnitude given a value of 8 point something, or 8.1, 8.2, they're going, then this should be of great concern to you. This should tell you that the effect or the implication will be severe. It will be very great. So take note. All right. Now, by far, in the event of the earthquake, among the various earthquake phenomenon that has occurred across many locations of the world, the maximum energy or magnitude recorded so far, or that can be recorded, is 8.6. 8.6. And when you have such a magnitude, that should tell you the sort of destruction or impact we should be expecting. That should tell you or give you an indication as to the sort of impact or the distractions that are likely to accompany such an earthquake. Now, look at few examples of earthquakes across the world. Now, on the 18th month of April 1906 in San Francisco, we had a great earthquake there, and this phenomenon measured 7.6 on a Richter scale. The magnitude of such quake or that earthquake was 7.6. So this should tell you the sort of destruction that this quake is likely to bring. A magnitude ranging or giving a value of 7.6. That is almost close to the great phenomenon that we look at earlier. All right. So the impact was that this quake destroyed the entire city of San Francisco, and it caused about 30,000 deaths. It caused about 30,000 deaths. It cost about 30,000 deaths. So take note. The San Francisco earthquake on the 18th month of April, on the 18th April 1906. And then the magnitude measured on the Richter scale was 7.6. And it destroyed the entire city, causing about 30,000 deaths. Let's look at another example. Another example. We have the Java earthquake. On May 27, 2006. Now, this measured 6.2 on a Richter scale. It measured a 6.2 magnitude on a Richter scale, and it caused about 6,200 deaths. It caused 6,200 deaths, and then an entire settlement was destroyed as a result of this quake. Let's look at another example. We have the Accra earth tremor. On the 6th of March 2000. Now, the magnitude of such a phenomenon, or this phenomenon, was 4.0. It was even discovered that the magnitude was less than 4.0. So the impact was just a small cracks developing on walls, and this was visible on the National Theater. We learned in the event of this tremor, we experienced, or we had cracks developing on our National Theater in Accra. Now, we are saying it is an earth tremor. An earth tremor because of the magnitude. The magnitude is less than 4. And I told you earlier that when we have earthquake phenomenon or vibrations that measures energy less than 4, we don't usually regard them as earthquakes. We don't usually consider them as earthquakes. Rather, we look at them as an earth tremor. These are just minor shakings or vibrations that develop or that occur on the ground surface. And this don't usually result in massive distractions as we see in other magnitude that ranges from 5.0, 6, 7, up to 8. So take note. Barely can you see any massive distraction with an earthquake measuring a magnitude of 4, below 4, or a magnitude less than 4. It is hard to find such an earthquake giving rise to a massive distraction or a lot of distractions. All right. Then we also have one very, very common earthquake that happened recently, some 10 years ago, and it happened in Haiti. So we refer it as the Haitian earthquake. It was one of the devastating earthquakes in recent times. It is one of the recent devastating earthquakes in recent time. Now, this occurred on the 12th day of January 2020. On the 12th day of January 2020, and the quake destroyed the entire city. It destroyed almost the entire Haitian city and killed about 200,000 people. So this should tell you how massive or how devastating this phenomenon is. That should tell you how worrying this phenomenon is. I quite remember during those times there were a lot of humanitarian crisis in Haiti, whereby the UN and other humanitarian organizations have to come in to help the people of Haiti come out or handle the impact of that earthquake. All right. Now, do you have any questions? Do you have any questions? Are you clear with all that we have looked at so far? The measurement of an earthquake, how earthquake phenomenon can be measured, the few examples that we have looked at.
Yes,
Yes, sir.
sir.
All right, so let me ask a
Yes,
question.
sir.
Let me ask a question. If you have an earthquake that measures 8.5 magnitude, if you have an earthquake of 8.5 magnitude measured on a Richter scale, will you consider that as a minor earthquake or a major earthquake?
A major
Major
earthquake.
earthquake.
8.5 will be a major earthquake. Okay, so in such, if that is the case, are we expecting to see massive destructions, or there's the likelihood that there will be no impact at all? Are we likely to see destructions?
Sir, come again.
Yeah, I asked whether you consider an earthquake with a magnitude of 8.5, whether you consider it to be a minor or a major earthquake. And you said that will be considered as a major earthquake. And I agree with you. So what I'm asking is that in
Yes.
such a case, are you likely to see massive destructions? Massive destructions, or you are likely not to see any destruction at all?
You are likely to see massive destructions.
Okay, so that is correct. That is excellent. Now, go through the Richter magnitude and its implications again. Go through the Richter magnitude or energy, and then its implications or possible effects once again. We are saying if you have a magnitude of 2.0 or 2, this phenomenon can barely be detected. What it means here is that people do not even notice that there's an earthquake phenomenon. So you can't tell whether there's an earthquake phenomenon because you've not experienced any ground shaking or any vibration at the ground surface. Now, when you have energy measuring 4.5, this is likely to send out some vibrations, and these vibrations are just minor vibrations leading to structural damages, possibly cracks on walls, and then perhaps some fittings getting damaged or destroyed. Then when you have a magnitude, an earthquake magnitude or energy measuring 7.0 or 7, this has the potential to cause buildings to get destroyed or buildings to collapse. So we refer to this type of quake as a major earthquake. We call it a major earthquake. Now, when you have an earthquake magnitude or the energy measuring 8.0. Now, we consider this to be a great or a severe phenomenon. We consider this to be a great or a severe phenomenon. And it is possible to see the ground shaking all over. It is possible to experience the vibration on the ground surface, leading to what? The shaking and then the trembling all over the ground surface. All right. Then the maximum recorded so far, that should tell you that we've never measured any earthquake magnitude or energy that gives us a value of 8.9. No, that has never happened. That has never happened. As at now, as we are talking, we've not had such an impact felt on the ground surface, or we've never had such a vibration recorded or measured on the surface of the earth. All right, so this is the maximum recorded, that is 8.6. And if such a phenomenon should happen, believe me, the impact will be very, very, very great. The impact will be very, very great. The impact will be even far, far, far beyond what we are likely to see when the magnitude is 8.0. So take note. All right, do you have any questions before we proceed? Do you have any questions? Do you have any questions?
No, sir. No, sir.
So you're all clear?
Yeah, me uncle.
Grace, are you clear? Are you okay? Grace, are you
Yes,
okay?
sir.
Is she there at all?
Yes, sir.
All right.
Yes, sir.
What of Savannah?
Yes, sir.
Are you clear? Do you have any question?
Yes, please. No.
Okay. I think our time is almost approaching, so we'll have to wrap up and end the lesson here. I've given you the examples of earthquakes as they have occurred across the world. We have quite a number of them. We have quite a number of examples of earthquakes that happened or occurred across the world. And these are documented. These events are documented. So you can go and explore more of these examples. You can go in and explore more of these examples. Look at the magnitude of the quake, and then look at the associated damages or implications or the effects. Look at the effects of such earthquakes. All right. Now let's look at some related terms on earthquakes. Under earthquakes, there are some related terms that we have to look at. So let's consider some of these terms. Now, before we experience or feel vibrations, the ground vibration at the ground surface, at the surface of the earth, these vibrations emanate or they originate from a particular location. The vibrations we experience on the ground surface or on the surface of the earth are sent or they emanate from a particular location deep within the earth crust or deep in the earth's interior. So the source, the origin, where the vibrations originate, where they come from, we have a name we give to the source. So the location where the shock waves emanate, where they originate, where they come from, we refer to this as the focus of origin. We call it the focus of origin. or the focus of an earthquake, the focus of origin or the focus of an earthquake, where the energy, is coming from, the source of the energy, the vibrations as they are felt or experienced at the ground surface, where these vibrations originate, is what we are calling the focus of the energy. The vibrations or the energies or the shock waves originate or emanate from a particular point within the earth crust. So this point, the point at which these shock waves originate, basically is what we are referring to as the focus of origin. All right. Now, when this energy or these shock waves move from a particular location, when they move from a particular location, they are felt, or the impact of these shock waves or energy are experienced or felt at the ground surface, at the surface of the earth. So when these shock waves or energy hit the ground surface, when they hit the ground surface or when they materialize on the ground surface at a particular point, we call this point as the epicenter. We call this point as the epicenter. These are points directly above the ground surface, directly above the ground surface or the origin, where the source of the energy is coming from or is emanating from. Once it hits the surface, the ground surface, the point at which this energy materialize or these shock waves energies are felt are what we are calling as, or we are referring to as, the epicenter. Are you clear?
Yes, sir.
Bright Elikam. Bright Elikam, are you there?
Yes, sir.
All right. So, for instance, if you have a fracture, if you have a crack or a fault developing deep within the earth crust, let's assume the depth is about 20 kilometers, 20 kilometers deep within the earth crust. That is where the fault has occurred. So that fault occurring at such a great depth within the earth crust is likely to release energy. It's likely to release energy. So that will be the focus. That will be the focus. That point deep within the earth crust where the fault or the crack develop, giving rise to the energy or the shock wave, is what we are referring to as the focus of origin. That is the origin of the energy. That is the origin of the shock wave before they are felt or experienced at the surface or any other direction. So take note. Now, when the energy or the shock wave develops as a result of the fault deep within the earth crust, they send out vibrations or energies. So these energies or shock waves travel from the central location, the point at which the plate comes into contact. They send out energies or vibrations into so many directions, So the point at the ground surface, directly above the origin where the fault has occurred, the point directly above the ground surface or the surface of the earth where the shock is experienced or where the energy is experienced is what we are calling as what? The epicenter. The epicenter. So let me give you this simple scenario. Um, Grace. Grace,
Say. Say.
let's assume you pick a stone. Are you listening? Hello, are you listening?
Yes, say.
Students, are you all listening?
Yes, say.
All right, so let's assume you take a stone and then you you decide to throw the stone against a wall. You throw the stone to hit a wall from a specific distance. Are you following? Now, your location, the point at which you stood before throwing the stone, that point in this regard will be considered as the focus of origin. That is where the impact that will be felt on the wall, that is the origin. That is where it is coming from. Where you stood or where you are standing before throwing the stone is what we are referring to as the focus of origin. Is that clear?
Yes, sir.
Now, when you
Yes,
throw the
sir.
stone, the stone will travel a distance. The stone will travel a distance before hitting the wall. So as the stone travels and then hits the wall, as it hits the wall, the impact of the stone as it hits the wall will be felt at a particular point, a particular location or portion on the wall. Is that not it?
Yes, sir.
Yes. So that point at which the stone hits the wall and the impact is felt is what we are referring to as the epicenter. It is the epicenter of what you have done. So your point where you threw the stone is the focus of origin, and then when the stone hits the wall, the impact felt there is what we are referring to as the epicenter. Is that clear?
Yes, sir.
Yeah. So bring this analogy or this idea into what I've just explained. The focus of an earthquake and then the epicenter. We are saying the focus of origin is basically the source region where much of the energy or the shock wave originates or comes from. We basically refer to it as the source of the energy, the source of the energy. So that is the focus of origin. Now, as this phenomenon occurs, the energy travels. The energy or the shock waves travels for a particular distance. Once they travel, they may hit a particular location where the impact will be felt, where the impact of such energy or such waves as they travel will be felt. So the point at the surface, directly above the surface, where this impact or the effect of the energy is felt, is what we are referring to as the epicenter. Is what we are referring to as the epicenter. So take note. Take note. All right. Now, what is the epicenter? The epicenter, we can define the epicenter as the point on the Earth's surface where the effect of a shock is greatest. Where the effect of a shock is greatest. So, like I said, if you hit uh, the stone against the wall, the point at which the stone directly hits the wall, the impact there will be greater than the other portions of the wall, because that is a point, that is the exact point where the stone, the impact of the stone is felt. So we expect to have a greater impact at the point at which the stone gets contact with the wall than the other locations or other portions of the wall. So take note, the epicenter is basically the point on the surface of the earth or on the ground surface where the effect of an earthquake is greatest, or where the effect of a shock is greatest or massive. I think our time is far spent. We have to wrap up here. And then I hope you can see an image on your screen. Students, can you see an image on your screen?
Yes, sir.
Yes,
All right.
yes,
So
sir.
the reddish portion, can you see the mouse pointer? The reddish portion.
Yes,
Yeah.
sir.
So that is deep. That is deep within the Earth crust. So this is where the fault occurs. Let's assume there's a fault occurring here. So the development of this fault or the development of the fault here will send out series of energy, and for that matter, this spot becomes the source of the energy. This spot becomes the focus or the source of the energy. This is where the energy travels from. This is where the energy travels from before getting to other locations on the Earth surface. Now, watch directly above the focus, directly above the focus. So as the energy is released or sent, or as the energy travels from the focus point here, as it travels and then hits directly the surface, directly the surface above, is what we are referring to as the epicenter. That is what we call the epicenter. Now, the impact at the epicenter of every earthquake is greater than any other location. Is greater or heavier than any other location on the ground surface. What I'm saying basically here is that when you have an earthquake phenomenon where the shock waves first hit, or where the impact of the shock waves are first experienced or felt, the impact there is greater than any other locations on the ground surface where these shock waves may travel. So take note. Now, the distance between the epicenter and then the focus of origin, and then the epicenter, the distance between these two will give us the focal depth. This is basically the distance between the focus and the epicenter. It's basically the distance between the focus and the epicenter. So that gives rise to the focal depth. All right. When we continue, we'll end the class here. Our time is almost up. So end the class here, end the lesson here. When we continue, when we come next week, we'll continue, and then probably we'll end the lessons on earthquake, and then we take it from there. Do you have any questions? Do you have any questions?
No, sir.
No, sir.
So if I ask all the questions under earthquake, will you be able to answer?
We will try.
You try.
Yes, sir. Yes, sir.
All right. Then let me ask you a
force.
question. Since you guys said you don't have any question, let me just ask you one question, and then we'll end the lesson. Exactly.
Okay.
Let me see. You guys are about 7. You guys are about 6 or so. So each of you will give me one possible cause of an earthquake, and I will end the lesson. So once you give me, then you can leave the class. So if you are ready, just raise up your hand. I'll call you, and then you give me one possible cause of an earthquake.
Please repeat the question.
Causes of earthquakes, or causes
Possible cause of a
yes, of an earthquake. Yes, Grace, your hand is up.
sir, volcanic.
Let me mention you before you respond to the question. I mentioned Grace. Grace, your hand is up. Grace.
Say,
Yes.
movements of plates within the Earth's crust.
So movement of plates within the Earth crust can bring about a result in earthquakes. Yes, Savannah, I see your hand up. Savannah. All right. Emmanuel, I see your hand up.
Sir,
Yes, Emmanuel, I see your hand up.
yes, say it occurs as a result of movement of force within the earth crust.
Can you come again?
It occurs as a result of movement of force within the earth crust.
Um, I didn't get you clearly. All right, Shadrach, your hand is up.
Okay, volcanic action.
Volcanic eruptions can also lead to earthquakes, right? All right.
Yes, sir.
Yes. Emmanuel, your hand is still up. Come again.
Sir,
Yes.
earthquake occur as a result of movement of the earth crust.
I can't hear what the answer you are giving. I think we have a network issue here. I can hardly hear what you are saying. Um, yes, Bright, are you there? So,
Yes.
Emmanuel, I think I've asked this question before and you answered. So, you can leave the class. Elikam,
Say,
yes, give me an answer and then you go.
it occurs when tectonic plates collide over each other.
We are likely to have earthquakes when tectonic plates collide.
Yes.
So you can say when plates collide. Okay, when plates collide,
Okay.
we are likely to have an earthquake phenomenon.
Okay.
Yes, Savannah. Savannah, are you there? All right. Savannah, if you can hear me, go and then prepare and come answer the question in our next meeting. All right. So, end a lesson here.